Welcome to today's discussion of lift, drag, and turbulence. Beginning with a disclaimer, an observation in published material that looks good but is not 100% good. I found this online and it's informative, but it's showing the Clark-Y profile at a positive AOI, and that's wrong. It's a 0-degree mount type wing. That's where they should be starting with their measurements and discussion here. So when I've copied it out and excised it and got it online so that the airflow projection is correct based on a 0 degrees AOI. It's this curvature of the Clark-Y and its type of profile, and the raising of this neutral line, or whatever it's called, above the 0 line. It's not parallel to the 0 line, it's at an angle to the 0 line. So the whole shape of the wing has a positive angle of incidence built into it, and I've discussed this in another tutorial. So, skipping over all of that, and you can see the captions that I've made to reference the things that happen, stated in a general way, together with a visual. I hope it will be effective. What's not understood or misunderstood in some cases is the fact that ambient pressure around the wing and under it when it's in flight is a constant, more or less. It's treated as a constant if you want to do the math. So, if you just treat that as 0, since it's a 0 degree AOI, if there was a thin sheet of ultra hard stuff, it would just slice through the air and nothing would happen. In a two-dimensional world, two-dimensional solid in a three-dimensional volume of air. Anyway, maybe that reads, maybe it doesn't. In any case, this stuff back here that was labeled wake is really turbulence. And it's really the key thing. It's a good thing. Turbulent air is less dense. That means the air above the wing in this area is less dense than the air down here. The wing gets caught in the exchange and is lifted up due to suction at the top. So the process of lift is, the point I'm trying to make is the process of lift is, it behooves a person to understand the word lift and what the process is that it describes. Until, when this thing is moving through the air, basically 0 is nothing happening at the lower surface. At the top, at the nose, we have a smooth splitting of air, and the shape, this is a shape that promotes smooth, laminar, non-turbulent flow up over the top. So the wing is hitting the air, the air is sort of hitting it obliquely, and then it goes clear past it. So there's a compression of the air up in here, which is in the inherent drag in the process, friction, compression, drag business. Okay, then it's sort of a plateau here. Then, as the shape falls away, the air pressure, laminar flow changes to turbulent. Turbulent is less dense. So this is where the process of lift is really happening. The less dense air and the more dense air beneath trying to fill it in. It's like weather, where the clouds move, the air moves from a cold place to a warm place because the warm place is rising. It's the same sort of analogous situation. It's just an object moving through a gas or fluid, you know, has these properties, and this is what model building is all about, because models don't have the same kind of distribution of mass and density of structure that any full-size Cessna has. I mean, things are just so completely different that a 0 degree, correctly designed 0 degree profile is just, it can't be beat. So I've said that before too. Sorry. Okay, this is typed out what I was talking about there. Just a general way of thinking about the process, without having to worry about lift and drag so much, but in terms of what the underlying process really is, and that's what I've been describing. And if you understand that, the rest should begin to make sense over time. The way this shape is this shape, and where it reaches its thickest point of profile, which is expressed as a percentage of the chord length, at 30%. That happens there. That's just a scientific fact. That's where it should do. On a small wing, on anything smaller than a Piper Cub, full size. So that's the reason. I mean, it's a mindset, perhaps. It's just little things that if a scratch builder wants to build a good model, see, all these little facts add up to good wing design and good airframe design, and an aerodynamically well-designed wing and airframe. And the wind-up of the discussion of how turbulence is a good thing. Turbulence equals the ambient air pressure pushing on the lower surface of the wing, so to speak. The wing is caught in this process of seeking equilibrium all around the wing, but because it's moving, it's a rolling process, it's a traveling process. So it helps to perhaps think about something going by in the background, because it's the wing that's moving. And so it just puts a slightly different spin on your thinking, possibly. I've learned some of this just through osmosis and the passage of time. So there you go. Maybe it'll help. Maybe it won't. I think that's the end. Thanks.